Okay guys, so today what I will do, I am going to basically start your cryptography. I think some of you is aware out there what is cryptography, but I will tell you, or we can say why we are basically learning network security in your SD-WAN. What is the reason behind this, or why we need a cryptography knowledge or cryptography knowledge to understand the SD-WAN completely. Then we will discuss what is CIA, confidentiality, integrity, authentication. And after that, what we will discuss TLS and DTLS protocol, their handshake. Then we will look for the PKI. What is the public key infrastructure? What is the CA server? What is digital certificate? What is root CA certificate? What is intermediate CA certificate? Then we will look for the identity certificate or end client certificate. Then we will discuss what is CSR, certificate signing request, how the validation happens for this certificate. Okay, so I will give you the advanced overview of these things, guys. And after that, we will look for the control connection and SD-WAN controller bring up events basically. And guys, let me just tell you, if you know these two things, how the things happening, and if you know the concept of your certificate authorities, and if you are doing the deployment from the scratch of your SD-WAN fabric, around 40% deployment you will able to complete with this particular knowledge only, guys, whatever we have completed so far. Okay, so this particular knowledge is required a lot. Why we are learning here network security, or why we are learning here cryptography? So let me just start with that, guys. So if you will see, I have taken here today one simple topology. So let me just go into my topology first. Okay, so let's suppose I just have this simple topology, guys, where I have two managed routers, VS1, and let's suppose this is the CS or CS1. These particular routers, they have a connectivity to this particular link. Let's suppose this is MPLS, or this may be your internet, doesn't matter. Okay, this is just your transport. This is your WAN environment. And after that, we have your controller. Let's say these controllers we are having in the cloud environment. So we have a vManage controller, vBond controller, and vSmart controller, right? So guys, if you will see, these controllers basically they will also communicate with each other, right? All these three controllers, they will communicate with each other basically securely. What is the protocol they will use for communication? They will use here DTLS, which is the default one, and they can also use TLS as well, guys. Both options we are having. And just remember one thing, your vBond, it always runs on DTLS. You have a TLS option for vSmart basically. If you want to run vSmart and vManage, that kind of traffic you can send through TLS as well. Don't worry, I will discuss what is DTLS and what is TLS in your session now. So because see, they are communicating over these tunnels, right? Which means whatever data they are exchanging with each other, that data is encrypted, right? That data is hashed also, which means they are basically maintaining here CIA properties. CIA means your confidentiality of your data, integrity of your data, and authenticity of your data. And apart from this, guys, you can see, because see, these controllers we are having over the cloud environment, right? But let's see, these WAN edges, basically this WAN router or this WAN router, they also wants to communicate with these controllers, right? They will also communicate with these controllers. Now, if you will see, these controllers traffic is going through the public environment, right? This is the public internet environment. Now, if you will send the communication, whatever traffic you will exchange between these controllers and this particular V is or C is routers. What will happen if there is any hacker? What he can do, he can capture the data running any kind of tool like Wireshark he can run, right? He can capture the data and he can see entire information, guys. Even though if you remember in last class, your V Smart, what it will do, it used to sends the crypto key, right? For encrypting the whatever traffic is flowing between these two devices, right? These keys also anyone can get easily. Now, if you want to secure and in your SD-WAN, because the communication between your V is routers or your controllers, it is also secure. And what they will use for the security, they will use the DTLS and TLS basically. What is this DTLS and TLS? It's just a normal SSL tunnel. I can say in simple word. It's just a normal SSL tunnel. Because they are communicating securely, right? With each other, which means now your cryptography is involved. Or your network security is involved, because now we have to understand how the network security is implemented between these controllers and these WAN is routers communication, right? Because they are communicating now on this communication, how they have implemented the network security, how they have just make sure whatever traffic is flowing between these devices, it is highly secure. So for that, basically what you have to, or we have to look for the all the aspect of your network security. That is the biggest reason we are here, to learn the network security. So if I will start explaining the concept of your network security, so what I will do, I'll just first tell you the normal communication basically. So let's suppose this is you. This is your PC1. Let's suppose your name is Ravel. Then here we have an internet, right? So this is your internet environment. And now behind this internet, let's suppose you have one more server here. Server one, let's suppose this is your the HDFC Bank server. And that server you have hosted over TCP protocol 443, let's suppose, or any port number. Let me just remove the protocol details. First, we will understand the basic aspect of it, and after that we will go little in depth. Now, let's suppose this person, what he wants to send some type of message to this particular server, and basically what in the internet, because this is the internet environment. So let's suppose we have one more guy here. He's a attacker or he's a hacker. The intention of this hacker is whatever communication is happening between this PC1 and this server, he just wants to capture and he just want to see all the information basically. So what will happen? Let's suppose this person, he send the one message towards this server, which is hi, let's suppose. Now this message is flowing through the internet, so there is a high possibility my hacker, what he can do, he can basically able to see this particular message. He can capture the Wireshark, he can capture the packet and he can see the information easily. This is very, very easy. He can see the information, whatever the communication you are is happening between this person and your server. Now, if you want to basically, if you want to add some security here, if you want to hide the actual message, what is the way you are having? So if you want to hide this message, what you can do, you can just do the encryption. What you can do the encryption. If you want to basically hide this message, what you can hide with the help of encryption. In encryption, what they will do, they will take out your message, they will apply one encryption algorithm. So I'm not putting here, they will apply one algorithm, plus they will basically need one key to encrypt this particular message. And after that, after applying the encryption algorithm and the key, what maybe your high will looks like this: AB star 12 hash. Now, if you will send this message over the internet, instead of the high, if you will send this message over the internet, if this hacker, he will able to capture your message, then when he will capture, when he look the content of this message, what he will get? He will get this particular thing. Now he is not getting the actual message, right? Now, when this server, he will receive this particular message, what he will do? This server receive this message, so what? He will also apply the same algorithm plus same key. This key may be different, but I'm just going with the same key. He will apply the same algorithm plus same key. And what he will do? Here we have encrypted the message. Now here he will decrypt the message. And after decrypting this particular message, what? This server, he will get the actual message, which is high, which is sent by the rebel. So with the help of guys now encryption, what we are achieving, one of the property of your security is known as confidentiality. Means with the help of encryption, what we can able to achieve the confidentiality of your data. Whatever data we are sending through this internet, it will encrypt. So guys, this particular data on which we are applying the encryption algorithm is known as plain text. What? This data is known as plain text data. And after the encryption, whatever data we will get, that data is known as a ciphertext. This data is known as a ciphertext, right? And after decrypting, what we will again get the plain text. Plain text is a text which we can able to read with the naked eyes, which means which human can understand. Okay, so with the help of confidentiality, what we can able to achieve the encryption, or we can able to, with the help of encryption, we can able to achieve the confidentiality on our data, guys. Now, let's see here one more case. Let's suppose this hacker is a smart guy. What he has captured your data, which is he has just got this message. Now, in this message, this hacker now what he can do? Either he can remove something from this data, or maybe he can add something in this data, right? Means now still he is able to tamper your data. Means still he can able to tamper your data. Now, if you want to protect the tampering of your data, because see, if your data is tampered, which means we are losing here integrity, right? What do you mean by the integrity? We are sending high, right? But at the other end, maybe here something else is reaching. Maybe instead of high, he received the Y, right? Because what he just data is tempered now. Your data is tempered now. If you want to protect that data from the tampering, what do you have to do? You can just add one thing. You can just run here one hashing algorithm. Just pass this particular ciphertext through the hash function. You can use any hashing algorithm, like you can use here MD5, you can use SHA, You can use SHA-1, SHA-256, anything. And what you will get here, you will get one fixed number, guys. Whatever, when you will run the hash on this data, what you will get one fixed number. Let's suppose you get the one fixed number, which is 1, 2, 3, 4, 5, 6, 7. I'm just going with the hypothetical number, guys. Now, if this hacker basically, he will tamper your data. And if your tampered data is reached to this particular server, what that server will do, in this tampered data, this server will also run the hash. And this time, because your data is modified, if your data is modified, this hash value will change. Maybe instead of 1, 2, 3, 4, 5, 6, 7, he is getting A, B, C, D, E, F. Maybe he's getting this particular data. So what it will do, it will match this particular calculated hash value and the received hash value, because when we will send this packet toward this server, we will also add this particular hash value there. And when this value is mismatched, because both value are not same, like that, what this server gets to know, oh, my data is tampered. This is how basically they will find out the tampering of your data, guys. Okay, cool. Now let me just design one diagram here. So I have the PC here. This is PC1. I have the internet cloud here. I am basically starting from very basics, guys. Okay, so you will get at least whole idea, and I will take you till the advanced level. Don't worry. Okay. And this is the server here. So this guy is Rebel, let's suppose, and this person is Anjali. You can put any name. I'm going with these names. Okay. Now what will happen basically when this Rebel or Anjali, they wants to communicate with each other? What's happening? Let's suppose this guy Rebel, what he just want to send some type of message. Let's suppose he has written one message. Let me just write here, hello Anjali, right? He has written this message. This is the message now this particular person wants to send to this particular server or Anjali. So what will happen when this PC, he will basically try to forward this message to what this server, what he will do? He will just apply the encryption algorithm. So he will apply the encryption plus he will apply one key as well. He will get one ciphertext. So let's suppose I'm just writing a simple thing. He will get the ciphertext, which is ABC star hash star 1, 2, 3, 4, 5, like that. He will get this value. Now, this is your clear text. This is your ciphertext. And now on this ciphertext, what I will do, he will also apply the hashing algorithm. Let's suppose after applying the hashing, he will get some hash value. Let's suppose he will get here hash value. So for the simplicity, I'm just writing here X, Y, Z, A, B, C. He just get this particular simple hash value. Now, when he will basically send the message over the internet, what he will do? He will send the message like this. This message have two things. This message having the ABC star hash star 1, 2, 3, 4, 5. So this is your ciphertext. He will send this ciphertext along with this particular value X, Y, Z, ABC. This is your hash value. Now, when this server, he will receive this particular values here. when this server received the value. So let's suppose this rebel, while encrypting this data, he have used one of the key, let's suppose key 1 or K1. This is the key he has used. For the hashing also, let's suppose he has used the same key, which is K1. Now when this server receive this packet, so the first thing what he will do, he will receive this packet. So this server, what he will do, he will basically take this particular hash value or this particular ciphertext value, and he will run the hashing algorithm. So let's suppose here we have used the MD5 hash value, then this person also run the MD5 hash value, and he will also use the same key, which is K1. And because see, these values are similar, which means he will also get the same hash value here, ABC. And after that, what he will do, he will basically match this value and this value. If these two values is matched, which means what he will said, he will basically consider there is no data tampering. If there is no data tampering, means integrity is maintained. Integrity is maintained. Now, after checking this value, basically, what he will do now again, what he has to do some calculation. So what he will do this time, he will again take this particular ciphertext. This time he will basically send this particular ciphertext through the encryption algorithm function. So let's suppose here we have used one of the encryption algorithm is AES. So here also he has to use the same encryption algorithm, which is AES, and he has to use the same key, which is K1. And if he will do the same thing, if he has this particular same value, which is same key, and if this server is using the same encryption algorithm, which means he will get the same message, which is hello Anjali. Let me just, it will get the same function, which is hello Anjali, this message. So this is how basically they will communicate with each other. But let's just remember, just see here one thing. Now guys, you may ask one question here, how this server know he has to use the key, which is K1? How this server know he has to use the encryption algorithm, which is AES? And how this particular server know he has to use the hashing algorithm, which is MD5? Right? This question maybe you ask, right? Which means now this PC and this server, they need some kind of mechanism, right? By using that mechanism, what they can do, they can able to basically generate the same key. They can able to basically also agree on these particular encryption algorithm and your hashing algorithm, right? So guys, your entire SSL, handshake, or your PKI environment is based on for these activities only. Your SSL handshake, your DTLS handshake, or your public infrastructure, your certificates and all, what? Everything is basically developed just for exchanging these particular keys and exchanging your encryption algorithm and hashing algorithm between the two network devices basically. Now, so what I can do now here, let me just explain you one thing. Let's suppose someone camera is on, guys, just turn on your camera. Okay. Okay, cool. So let's see. Now there is a one more thing basically. We are able to achieve the, so guys, the main purpose of network security to basically maintain the three properties of your data. CIA. C stand for confidentiality, which we can able to achieve with the help of encryption, right? I is your integrity, means integrity of your data we can able to achieve with the help of hashing algorithm. Now still there is a one more thing is pending, which is authenticity, which means how this particular guy or rebel, he will make sure he is communicating with the right person here, right? Let's suppose they wants to do some kind of business with each other, right? How they will basically trust on each other, and how Anjali will trust he is the right person, right? So let's suppose if they wants to trust on each other, so let's suppose what they have done, he is having some kind of ID, he has some kind of identity here, and this Anjali, he is also having some kind of identity. Now who has just provided this identity? So like guys, let me just give you one simple example. Let's suppose when you will basically go to any international countries, when you will go to airport, what they used to check your passport, right? They used to check your passport. In your passport, if you will see, you have some details, right? You have your name, your worth, your address, all these details. Along with that, you also have a one signature of your government, right? Maybe if you are from India, then you have a signature there of your Indian government, right? Which means your passport is issued by government of India. That is the reason they have a trust, because they trust on this particular government of India. This is the trusted person basically. This is the trusted guy. If this guy, he will provide the identity to anybody over the internet, all the device they will trust basically. So let's suppose here, in similar way in your internet world, we have here something called certificate authority. What we have is something called certificate authority over the internet, and this certificate authority, the job of this person is to provide the digital identity to this person and to provide the digital identity to this person. And when they will provide this digital identity, what they will do, they will put their signature. I'm just going very simple here. They will put the signature. So this CA server, what he will do, he will put his signature here on this particular ID. In Anjali ID also, this CA server, he will put the signature. Now, when this Ravel and Anjali, they wants to communicate with each other, they will present their identity with each other. What? They will present their identity with each other. Now this Anjali, when he will check the, when he checked the identity of this Ravel, what? Because this identity has a signature of this particular server or this particular CA, because Anjali has a full trust on this person. And if something is issued by this person, your Anjali will automatically trust. So that's how they will basically make the trust on each other. That's how basically they will authenticate each other. They are communicating with the right person, guys. So this is the simple definition of your encryption, hashing, and your authentication. Or we can say this is how your CIA properties maintained over the internet, guys. Now let me go little bit advanced. So guys, any questions with regards to confidentiality, integrity, and authentication? So Rahul Singh, you are wrong. A is your authentication, it's not availability. Okay, just remember. Cool. Okay, now, so guys, if you will see, and I think everyone know, right? Over the internet, your protocol like your SSL, which is also known as your HTTPS protocol, or your TLS, or your DTLS, your IPsec protocol. What they used to provide the three properties which is known as CIA: confidentiality on your data, integrity on your data, and authentication on your data, which is also known as authenticity. Now, what I can do, now in your encryption, basically, now let's discuss the encryption. So what I can do, if I'll take the help of my notes, that will be great. So where it is, okay guys, so in your cryptography we have a three main properties. First one is confidentiality, which we easily achieve with the help of encryption, which means we will encrypt our plain text into ciphertext. That process is known as encryption. And from ciphertext to get the plain text, this process is known as decryption. Integrity, we can achieve with the help of hashing. And guys, your hashing is a one-way process. It's just a one-way process. Let's suppose this on you have basically run the hash on some data you have here, and if you run the hash, who is this person actually? I'm not sure why people, guys, just turn on your camera. Actually, don't want to repeat again and again. Actually, let me see if I have anything. Allow participant. Let me just disable that option. Cool, guys, my screen is visible properly. Okay. Okay, guys. Now let me just start. So your hashing is a one-way process, means what you have to do, let's suppose from on this value you have run the hash. Let's say here you have a value of A, B, C, D, E, F, this kind of value you are having, and you will, let's say you will get the hash value which is 1 2 3 4 5. Now with this hash value you will not able to get this value. Basically we don't have any kind of process. It's just a one-way process, means reverse engineering is not possible for your hashing, guys. Just remember. Now so let's suppose, now guys, let me just discuss your encryption. So for encryption, basically, so encryption is a process, it's a simple process of changing your clear text to ciphertext, right? Now in encryption we have some kind of algorithm, guys. So the thing is, we have a first type of algorithm which is DES. No one uses nowadays this DES. Then we have a 3DES. Then we have a AES. In AES, we have a size. We have a 128, we have a 256. In most of the organization, they are using AES 256, guys. We have a RC4 as well. Apart, these are the popular one. Apart from that, we do have a lots of other algorithm as well, guys. Okay, these are the some encryption algorithm. Now, we can do encryption in two ways. What are these two ways? We have a asymmetric encryption. We have a asymmetric encryption algorithm. and we have a symmetric algorithm. Or we have a asymmetric encryption and we have a symmetric encryption. So these are the two types of encryption we are having. So guys, now what is the difference between symmetric encryption and asymmetric encryption? So guys, your asymmetric encryption, what? Here we have a two keys. What we will do when we use the asymmetric encryption algorithm, first we will generate the private key. Then guys, with the help of this private key, we will generate the public key. So your asymmetric encryption has two ways, private key and public key. Now, in your asymmetric encryption, what happens? Let's suppose you have decrypted something with the help of, let's suppose you have encrypted something by using private key. You are only able to decrypt it with the help of public key. Or let's suppose you have encrypted something with the help of public key. Let's suppose you have encrypted something with the help of public key, then you are only able to decrypt it with the help of private key. So which means simple thing, if you will use this particular key for encryption, then we need the another key for the decryption. If you will use the public key for the encryption, then you need a private key for the decryption. That's how this thing works. So guys, now in symmetric encryption, what? We have the same key. What? Here we have a similar key. Means we use same key for the encryption and same key for the decryption. Means let's suppose we have a key equals to K1, which means we have to use the K1 for encryption and we have to use K1 for the decryption as well. Now, what is the major difference between symmetric and asymmetric encryption, guys? So your asymmetric encryption, because you will see here, we have to calculate the two keys, right? Which means if we will calculate the two keys, so asymmetric encryption is a CPU intensive. Means asymmetric encryption requires lots of CPU on your laptop to basically do the encryption. But in symmetric encryption, it is a less CPU intensive activities or process. So guys, now in the production environment, just remember people always use the symmetric encryption for encrypting the actual data. But they will use the asymmetric encryption as well for exchanging some type of keys basically, which means in our last discussion I have discussed they have a K1, these keys, how they have exchanged these keys. So means this asymmetric encryption algorithm we use to generate this particular key one. How it happens, let's discuss this thing now. So what I can do, let me just remove these things. Okay, so guys, before going into that, let me also tell you one more thing. Let me just complete the hashing as well. Hashing will take care of the integrity of your data. Now we have some hashing algorithm. So the first hashing algorithm is your MD5. Nowadays no one use this one. Then we have a SHA-1, we have a SHA-256, we have a SHA-512. So these are the some hashing algorithm we are having, guys, and we use these hashing algorithm to take care of the integrity part of it. Now if you will use these hashing algorithm, you need a key, guys. Always you need one key. Okay, you need a one key here as well. So this is your hashing. Now let's basically discuss your asymmetric encryption in this environment where we have a PC1 and server 1. So let's suppose Rebel or this PC1, he is having two keys. So let's suppose he has a private key. Let's suppose K1, and he has a public key. Let's suppose public key is K2. Now in similar way, this server also have the keys. He is also having the private key. So private key, let's suppose equals to here K3, and we have a public key here which is K4, right? This is the public and private key we are having at the server end and at the PC1 end. Now, if you will see here, guys, we have a public key, right? Which means this public key we can share with anyone. This key we can share with anyone. Only we will keep our private key secret. Basically, we never share this private key with anyone, and your server will also not share this private key with anyone. This public key he can share with anyone. So let's suppose this Rebel and Anjali, they have used some mechanism, and that suppose they have shared their public keys, right? So your server 1 public key is reached at the Rebel PC, which is K4, and the Rebel public key, which is K2, is also reached at Anjali PC or Anjali server, right? So I can mention here PC1 public key, which is K2, and they have exchanged these public key by using any media, guys. Maybe they have exchanged manually or anything they have used. They have shared these keys. Now, guys, let's suppose now this person Rebel, he wants to send some message to Anjali. Let's suppose he wants to send one message. So let's say he is just sending this particular message. He is having this detail. He has sent my password is xyz@123. This is the text this person he wants to send to Anjali. Now what he will do? Now while sending this particular message, what this Rebel he will use? He will use the Anjali public key, guys. He will use this public key. And guys, during when they have exchanged these public keys, they have also basically agreed they will use like AES 256 as an encryption algorithm. They have discussed this particular algorithm they will use, and so he has used the key which is K. He will get some values here, right? He will get some values like that. Any values basically you can mention. He will get these values. After the encryption, this is your encryption is applied. Now on this data, on encrypted data, what he will do? He will apply the hashing algorithm. Let's suppose they have agreed to use the SHA-256 as a hashing algorithm, and they will use this K4 key here. And he will get some values as a hash function. Now when this server or this Anjali, he received this packet. So he has received this entire packet. What he will do? Now guys, Mr. Rebel, he has encrypted this particular data and has with the help of Anjali public key, which is K4, right? Because this Anjali now he has the private key, which is K3, right? So he will apply this K3 key. He will basically first generate the hash with the help of 256. They will match the hash value. If both is matched, which means data is not malformed. And after what they will do, he will use the same key and he will apply the decryption on it with the help of same algorithm. Now he will get the actual message, right? He will get this particular message here. So now guys, with the help of your public key and private key, they can able to communicate. Now let's suppose now this server Anjali, he wants to also send some message to Rebel. Let's say he wants to send one message which is okay, I received. This is the text he wants to send or she wants to send. So what will happen? Now on this text, if she wants to encrypt this data, what she will also use the Rebel public key, which is K2. And then she will also use the same hashing, same encryption algorithm and same hashing algorithm, right? And he will encrypt the message and he will basically add the hash value and he will forward towards the Rebel. When Rebel received, he will apply, he will decrypt with the help of K1 key. So like that, this particular communication is happening, guys, which means with the help of these public key and private key combinations, guys, what we are able to achieve the confidentiality easily, and we are also able to achieve the integrity. But the problem with this communication is that because we are using here public key and private key, so it's a CPU intensive job. So what they will basically, they may do, what they can do, they will just, instead of sending these messages, what they will basically maybe send this Rebel, he will send the encryption key. What he will send, he will say, let's use the encryption key which is K10 towards the Anjali. Anjali received the K10. Now Rebel and Anjali, they know they have to use the K10, which means after that they can use the K10 key for the encryption and hashing purpose. So which means your all your data or your traffic, they will basically use the symmetric encryption. They will use your combination of asymmetric key, which is public key and private key, just to exchange this particular key. And this key is known as, guys, session key. This key is known as your session key. Now, but the problem with this communication is that still this guy is not sure he's communicating with the right person or not, right? Now, how he has solved this problem, guys? How they have solved this problem? They can solve the problem if they will get some kind of assurity from someone, right? Let's suppose we have one person here, CA server. If this CA say to Rebel, Anjali is a right person, you can able to communicate with her. Or if this person, CA server, also go to Anjali and he just say, Rebel is a good person, you can do or you can communicate with her. Like that, they will basically authenticate each other. Now, by with this, with that particular thing, now let me just do some changes here, guys. And now I will basically implement your concept of your certification. Okay. Now let's suppose in the same environment, now we have here CA server. This is the certificate authority server. And let's suppose instead of this is not an Anjali server now. Let me go with the actual internet here. This is not Rebel. Now, let's suppose this is the SDFC bank server. Now, this SDFC bank server, what he is having? He is having, again, he's having same thing. He's having private key and he is also having the public key. So what he will do, this SDFC bank, he will do, he will basically reach out to the certificate authority by with the by, and also when he will reach out to the CA server, So CA server will provide the identity. When he will reach out to this CA server, what he will basically provide his information. What he will provide his common name, which is CN detail. In CN he will mention I am SDFC Bank. So he has mentioned sdfcbank.com. He will basically also provide his address, which is basically he will provide the country details. Or let me just go like that. Apart from this, what he will provide his country. Let's suppose they have hosted this server in India, so they have provided country is India. They will also provide the state. So let's suppose this bank is in Mumbai location, so they will provide the state, which is Maharashtra. And let's suppose they will also provide the city, which is Mumbai. But apart from this value, guys, they will also add his public key, which is K4. He will add his public key. So this entire thing basically what this server he will forward to us, the CA server. Now what this CA server will do when he received the certificate request, and guys, this request is known as CSR, certificate signing request. Now when this CA server he has received this particular certificate signing request from this server, so what he has done, first he will basically verify all the things. The requester, what he will certificate authority will verify this is the right person or not. He will verify this is the actual SDFC bank or not. After verification, when he will do all the verification, and when the CS server he will find out this is the right person. So what he will do now, guys, just understand here what they will do, because guys just remember one thing also here. Let me just add now. Your CA server basically also have the private key. Let's suppose which is here K5, and your public key. The CA server also have these keys, guys, okay, which is let's say K6. So now after receiving the CSR request from this server, what he will do, this CA server he will basically take this particular request, and what he will run the MD, he will run the hash function. And for hashing function, they will write now using SHA-256 as a hashing algorithm. On entire value, they will run this particular hash function. And after that, whatever value they will receive. So they will receive some value here. So let's suppose they have received this value. XYZ ABC 1 2 3 5 6, like that they have received something. Now when they have run this hash function, basically for running this hash function, what they have used the private key basically, which is K5. And after that, basically what they will do now, whatever hash function they will receive, they have basically received, what they used to do, they used to now run the encryption on this hash values, which whatever is generated from this CSR, they have encrypted this hash value with the private key, which is K5. And now whatever value you will get here, let's suppose after applying the encryption, you will get one value. So let me just go here, star hash equals to 9 10 20 30 ABC. Let's say you have get this particular value. Now guys, this value is known as a digital certificate. This value is known as a digital, not certificate. This is known as a digital signature. So your every certificate, they have this particular digital signature, or this is also known as your thumbprint. What? This is also known as the thumbprint basically. And guys, because or this CA server, he's having this private key, right? Which means this CA server private key he can share, right? So let's suppose this CA server, he has shared this private key with everyone, with all the computer. Like if you are using, if let's suppose this is the, let's suppose certificate authority, which is DigiCert, which means every computer, every mobile device, or your Chrome browsers, they have the root certificate of this CA server. On what you will get in that root CA certificate. So on, let's say on your PC, you have a DigiCert's root CA. DigiCert root CA. Now this root CA, what he is having the public key of your CA server. In our case, what is the public key is K6. What is the public key? Public key is K6 here. Now guys, what happens? Now this server basically, this CA server, he has created this thumbprint, and after that what he has just issued the certificate to this server. That certificate is known as identity certificate. Identity certificate. Now this identity certificate, he is having all this detail. He is having the CN detail, country detail, cities, and he is also having the private key, sorry, public key of your HDFC bank. And this particular certificate is also having this particular thumbprint, this identity certificate. So your identity certificate have, let me just write it is having the K4 value and it is having the thumbprint value. Or we can say it is having the digital signature of your CA server. This is the digital signature of your CA server. Now, when this server basically, when this PC and this server, they will communicate with each other, this server, he has presented his this particular identity certificate. So he has presented his identity certificate. In this identity certificate, what he has sent the K4 value and he has sent the thumbprint, right? Now, when this PC has received this certificate, now this PC, how he will basically make sure this certificate which is presented by this server is actually signed by this CA server. So what he will do, because this PC1, he is having the root CA of that particular CA server, and that root CA is having the public key, this public key of this CA server. So when he received this thumbprint value, right, he received this thumbprint value, what he can do, this PC, he'll basically take out the thumbprint value, and what he will do, he will just apply the encryption, and he will use the K6 value here, and after that what he will get this particular value, right? He will get this values, right guys? He will get this values because after encryption we will get this, and when we apply the decryption, so guys here it is not applying this decryption, it's encryption. After applying the decryption here on this thumbprint, he will start the decryption with the help of your root CA or your certificate authority public key. He will get this particular value. And also this server, because this identity certificate is also having the all the details, your public key, your address and all. So on this values, basically what he will do, this particular PC, he will also run the hash. What he will do, he will run the hash basically, and he will, if he is able to run the hash, and he will get the same value, which means like that they will validate, or basically they will verify they are communicating with the right person basically. So this is how your things happens in the production environment, guys. Like that they will do the validation, or like that they will basically do the verification. So this is how they will do the verification, guys. Now, if I'll explain the similar thing here, so if I'll go into my browser, if I let's suppose I will open here HDFC Bank. I have opened the hdfcbank.com here. So if I'll see the certificate of this HDFC Bank, let me just open this certificate. Connection is secure. I'll go certificate is valid. Let me just open the certificate here. Now, if you will see, this certificate is issued to www.hdfcbank.com. Issued by GeoTrust. This is the issuer of this particular certificate, and valid, this certificate validity is till 2023. If I'll go into the certificate path here, I have this, but I will get this certificate path. Now, guys, because while I have communicated with this HDFC Bank, so guys, here just see, there is one more thing. He will not present the certificate basically, or the server certificate only. He will also present here entire certificate chain. What? He will present the Digi cert certificate, then the intermediate certificate, and after that the identity. I mean, it will put the entire chain basically. It will send here entire chain of the certificate. Okay. Like that we can see we have all these three certificates. Now, if you will go into this HDFC Bank, go into the detail, it is having the version, then it is having the serial number. Then this is the signature algorithm is used by the CA server. They have used SHA-256 and RSA as a algorithm. Signature hash, they have used the SHA-256 as a hashing algorithm. Issuer, this is the CA server details. Valid, this is the validity. Now, if you will get, this is the subject detail they will exchange. Your CN, common name, your organization detail, your location, which is Mumbai, state, Maharashtra, country, India, serial number, all these details it will send. But in this certificate, you will also get the HDFC Bank server public key. So here, whatever key I have written on my explanation here, this one, public key, which is K4, this is the K4, guys, in actual. This is the big number basically. And after that, these are the parameters, subject key identifier and all, subject alternative name. So you will also get the send detail. Now, the most important thing is here, you have to look for this thumbprint. This is the hash value, guys, or this is the encrypt value. This one. This value, the last one, which we have received after the hashing, then on hash, encryption is applied. And once this encryption is applied, we have basically get the one value. That value is this one, guys. This is the thumbprint basically. Apart from this, basically, if you go here, let me just open the certificate. Apart from this, if you go into this path, because see, we have an entire path, we have a DigiCert certificate as well. This is the CA server root certificate. If you click on view certificate, it will open here and you can able to view all the details. Certificate path, you can see the details. It is also having the thumbprint. This is the CA server, and also, guys, it is also having the public key. This is the public key of your root CA server. And even though if you will open your laptop, so let me just type here cert manager. I'm just typing on my another screen, guys. Let me just open. So if you will see, this is the local certificate store on my laptop. If you will go into the trusted root CA and certificates, and if you will look for DigiCerts, go into the path. This is the actual certificate. DigiCert High Assurance EB root CA. So we have a multiple certificate for DigiCerts. This is the one, I hope. Let's just open it. Let's verify the thumbprint on this one and just verify the thumbprint here as well. 25, these values are similar, which means whatever server, because server, he has presented the entire chain of certificate, right? So how the validation is basically done on this place here on the PC, because when we receive this chain, right, if anyone will modify your root CA on the path, if anyone modify your intermediate CA on the path, we do have the same certificate in our store as well. So they will basically check the DigiCert thumbprint. If these values are matching, which means it's a right certificate. It's a right certificate. Basically, this is how they will basically do the things. This is how they will do the validation, guys. That's the validation process for these particular certificates and all, guys. Okay. Now, just guys, give me 1 minute. Let me just drink some water. Now, so guys, this is how they will basically, or your PC will validate the server certificate. Now, in this server certificate, he will get the public key of this server, right? This public key we have received, which is public key, which is K4, which means we have received the K4. Now, what this PC will do, now he has the session key basically. All in actual, basically, if I'll tell you according to your SSL handshake, what your PC1, he is have something called pre-master key. Now, this pre-master key, this PC will encrypt with this K4 and basically send towards the server. Once this server, he received the pre-master key, because pre-master key is encrypted, right? He will send this key in an encrypted way, guys. This pre-master key he has encrypt with this particular server public key, which is K4. Now when this server received it, he has the private key, which is K3. So he will decrypt it and he will get the pre-master key. Now with this pre-master key, they will use the random number and all. They will generate the master key, and after that they generate the session key. Same thing will happen here as well. So, and like that, basically they will successfully generate the session key. Now this session key they will use for exchanging the actual data, guys. This is the key which they will use for exchanging the actual data, guys. Now, so this is how basically your CA, also known as public key infrastructure, play a role. And what is the main role of the CA server? The main role of this CA server is to provide the authentication between this PC and this server. How they are providing authentication? They are providing with the help of certificates and all, right? With the help of certificates, guys, they are providing the authentication. So that's how basically your communication happens in case of your SSL or your TLS connections, guys. Now, go here. We have seen this symmetric key, asymmetric key encryption. Same key is used to encrypt and decrypt the data, right? Symmetric keys, host A and data. I will not explain this thing because we have already seen. Now, your public infrastructure include digital certificates, certificate authority or CA server. So guys, we have around 7 to 8 root CA. And after that, because see guys, when internet is started, these 7 to 8 root CAs, they are able to sign all the certificate requests basically. But nowadays volume has been increased. So what they have also created multiple intermediate CAs. So we have around 25 intermediate CAs, which means we can also get the certificate from intermediate CA guys. So that is the reason when we have communicated or when we have connected with this HDFC bank, we have get these. So if in this, if you will see, this certificate is belongs to the HDFC bank. This certificate, the middle one, is your intermediate certificate authority or ICA. This is your root certificate. This is your root CA, the main CA basically. And if we basically trust on this root CA certificate, which means we will trust on this and we will trust on this. That's how your trust is established over the internet. Okay. Now let's go back here. So we have some public CAs, which is GeoTrust, VeriSign, GoDaddy, DigiCerts. Right now it is Symmetric. Google CA is there, RSA is there, Intrust is there, CyberTrust is there. So these are the some public CA authorities, or these are the some public root CAs from where we will get the certificates. We can also use the private CA server. These are our local CA servers. Like if you will see on our topology, when we will do the configuration, when we do the end-to-end configuration, if you will see, I have introduced here one Linux server, right? So what I can use this Linux server as a CA server. I can also use vManage as a CA server. And right now, if you will see on my topology, I am using vManage as a CA server. So if you go here, if I log in onto my vManager, admin and admin, and if I go inside the vshell, ls-l, you will see this is the this is the private key of your CA server. This is the root CA key. This is the root certificate of your CA server. This is private key. This is the root certificate. If you want to see the private key, you can just simply do the cat, and it looks like this. This is the private key of your certificate, guys. And if you will see the certificate, this is the root certificate, cat root CA. You can see the certificate details. If you want to, let's say you want to see what are the details we are having here in this certificate. Copy the content, open notepad, save it, save this file as a save as, just give the name all, just give vmanage root CA .crt. Just save on this format or .cr format as well. It will work. Close it. So I think where I have saved, let me just see. I think it is on my desktop somewhere. Okay, I think I have saved on to some other location. So let me just save one more time. Save as root CA of vmanage dot crt. Desktop. Click on save here. Now, let me minimize my screen. Now if you will go here, and this is the certificate which I have saved. If I'll click on open, I have opened this certificate. See, this certificate is used to Sianets.com. You will get the detail. This CA root certificate is not trusted. This is a different thing. And you will get all the details on this certificate. This is the thumbprint of your root certificate. If you want to see how your certificate signing request looks like, if you run this command ls-la, you will get some CSR. If you will, let me just show you this CSR. Get. So this is the CSR. If I'll open this CSR, and let me just do the same thing. I will open Notepad. I will save as CSR dot CRT. Close it. This is the CSR basically. If I'll open this CSR, so it is invalid. CSR, let me just save this like that. I'm not able to open it properly, but these value you will see, these are the value of your, it is includes your public key and your organization details, your country, all these things. Okay. It's the same thing basically. Cool. So what your CA will do, what is the job of CA? What it will do? Issue a identity certificate or a digital certificate to the servers. Recognize all over the world, which means if something is issued by this particular CA, which is public CA, it is basically recognized and trusted by everybody across the globe. Digital certificate are used in SSL, IPsec, 802.1x authentication. CA root certificate validate the identity certificate of the server. That's how they will do the validation. CSR, it's a certificate signing request. It having following information: your name, your organization, your city, your country, your organization, your public key, right? We send the CSR to CA, and CA will provide you the certificate chain, which is having your identity certificate, your intermediate root CA, and your root CA. You will get this kind of chain from the certificate authorities. If you will see, I do have one more certificate here. If I run this command ls-la, you will see v1 id.crt. Let me just open this certificate. This is the identity certificate of my v1, guys. This is the identity certificate of my v1. So I'll open the notepad again. I'll save as here v1.crt. Now, this is the B1 certificate. This is the end user certificate like we have for SDFC Bank, guys. See, it is issued to B bond. This is the detail issued by Sianets.com. This is the path details. You will get all the details. You will get all the details right now. This is the end user certificate. You will get the subject name, right? Supports at the date viptela.com, right? This is the B1 details. Sianets.com, right? This is the location and country and all these details. So, okay, cool. Now, so we have seen the CA server, which is a certificate authority. Digital certificate, this is the end user certificate. Root certificate, intermediate, these are the CA servers. Identity certificate is a end client certificate. CSR is your certificate signing. We have seen how the verification happens for the certificates. Certificate chain, it's an entire chain basically. When whatever we will received here, this is the chain. Even though if I'll open like Sianets.com, our organization is also having the same details. You can see it here. This is the path of the certificate. If you go into it, is also having the same detail along with the thumbprints and all. This is the signature of your CA server. Okay, so we will have everything here, guys. Now guys, let's discuss what is your TLS or DTLS protocol and what is the handshake basically. So guys, let me just tell you one thing regarding your SSL handshake, basically how the SSL handshake happens, which is also known as your TLS handshake. How it happens, I have already uploaded one videos on your drive, or not on drive, on your course here. If you will see SSL handshake with Wireshark capture, so I have done lots of captures and everything, so that you can just check out this particular video where you will get the whole idea of your SSL handshake. Now what I will do, I will just tell you the what is DTLS, because TLS videos we already having. So let me just go with that DTLS only. So let me just go with the DTLS. So this is the some information of your SSL handshake. All these things I have covered in detail, guys. Don't worry about it. Okay, how SSL handshake is started, everything, even though each and every packets I have explained with the help of Wireshark captures, guys. Okay, so what I can do, your DTLS stand for datagram transport layer security, which means your DTLS is also a transport layer security protocol, guys. It is also transport layer security, but it's a datagram transport layer security protocol. Means DTLS works similar to your TLS works. What is the job of your TLS protocol? To provide you the CIA, right? Confidentiality, integrity, authenticity while you are communicating with any of the servers. This is the main job of your TLS protocol. Your DTLS will also do the same thing. The major difference between DTLS and TLS, your TLS, it runs on TCP. So your TLS is a application layer protocol, guys. And TCP as a transport layer protocol for your TLS connections. Okay, so it will use TCP in your transport. Now your DTLS. DTLS is also application layer protocol, but at the transport layer, it uses the UDP protocol. So it is similar to TLS and it uses UDP protocol for the faster packet delivery. So guys, everyone know, if our communication is happening on UDP, then UDP communication is faster. Your TCP communication is not that much fast. TCP is used by the SSL or TLS because of the need of packet reordering, retransmission, and reliable delivery of your data. So guys, let's suppose you want to do the retransmission if your packet is lost. If you want to, if you are receiving the packets out of order at the receiver end, at the server end, your TCP will take care of the reordering of your packets. It will take care of the retransmission if any of the packet is lost, which means it will provide you the reliable delivery of data. Means whatever you will send, it will 100% reach till the server. This type of guarantee you will get in your TCP. So which means if you will use the TLS, which means you will get the 100% guarantee for the delivery of the data. But just remember one thing, there is a one problem basically. Let's suppose you have some type of delay sensitive application, and if you are running these application over TLS tunnel, that time the application performance is not up to the mark, which means these are the some video and voice traffic, and you are not getting very good performance of that application if you are using TLS. So if at the same time, if you will use the DTLS, your application performance is very good. So in such kind of cases, basically, we will use the DTLS because DTLS is fast. But in DTLS, there is some problem basically because it works on UDP, and your UDP will not guarantee if there is any packet loss on the path. It will not basically do the retransmission for these lost packet. There is a problem with the fragmentation, right? Because we don't have any kind of maximum segment size concept on your UDP header, right? We don't have anything, these kind of things on your UDP. So guys, what people have done, they have taken the TLS. On the TLS, they have done some modification. They have added some extra fields, and they have just make the DTLS. And your DTLS, it will use for the transport, which is UDP. Now, what are the changes they have done in DTLS so they can get the retransmission if your packet is lost? You will get the fragmentation. So how you will achieve these things in DTLS? So guys, as you know, DTLS works on UDP. UDP will not provide you the reliability and fragmentation. So DTLS will take care of that packet loss. So guys, so in TLS, TCP is providing these fragmentation and reliable delivery of data, but in DTLS is itself doing the things basically. It will take care of the packet loss, it will take care of the reordering, and it will take care of the fragmentation. And also it will provide you the CIA like you will get on your transport layer security TLS. So how DTLS take care of the packet loss? So guys, what it will do, for basically packet loss, your DTLS will use the timers basically. Means if the packet not reached within the time, in that case, your packet retransmission will occur in case of DTLS. So they will use the timers basically for take care the packet loss. How they will do the reordering of the packet? So guys, in your DTLS header, what they have done in your record layer, they have added two values, sequence number and epoch field basically. Your sequence number value will increment for each packet sent between client and server. So guys, your DTLS use the sequence number for reordering of the packets, which means let's say you have received the out of order packet, means let's say this is the sequence, packet number 1, packet number 2, packet number 3. This is the order. When you will receive at the other end, maybe you have received packet number 2 first, then packet number 1, then packet number 3. These are the out of order packets. You are not receiving on a proper order basically. So in your DTLS, sequence number will take care. And DTLS uses the windowing system for anti-replay protection attacks and all, right? So if I'll open here the DTLS handshake. So guys, if you will see these are the real packet capture which I have taken from our topology, which is this one. And this is I have captured the communication which is happening between Dubai router and your vBond. Between your Dubai router and your vBond. Let's see. You will see some client hello. And after that, basically start looking from here. You have received the client hello packet from 10.61.1. This is the IP address of your WAN is in your Dubai location, and 10.1101.11 is the IP address of your vBond. You have received the client hello message. Now in this client hello, if you will see, this is they are using DTLS version 1.2. At the transport, they are using UDP protocol. So you can see the UDP here. Now you will get all the details. You will have a random number. So like in your SSL handshake or TLS handshake, we have a random numbers. They will also exchange these random bytes. Let me just show you something here, so you will also understand the thing. SSL handshake plus CloudShark. Let me open. DTLS handshake plus CloudShark. So let me open these captures, guys, here. Even though I have discussed all these things in detail. So see, when your SSL handshake is started, first they have gone through with the TCP three-way handshake, and after that your SSL handshake is started, right? Client hello, server certificate, server hello done. But in DTLS, see the thing, you just have a first packet is your client hello packet. This is the first packet which is client hello packet, and in our case also we have a first packet which is client hello packet. Now see that this first packet which is client hello, open this client hello packet. So this is the SSL packet, guys, or TLS packet. They are using TLS version 1.2. It is using TCP as a transport layer protocol, and just open the secure socket layer which is SSL packet here. See the details here. You have the random number, you have the random bytes here. In your DTLS also you will see the same. They are using UDP here, and just see the values here. You have the random number. This random number they will use while basically they will generate your master secret and pre-master secret, guys. It is also having the session ID length 0. You will get the session ID 0 here as well. And same thing you will get into this packet as well. Session ID length is 0. Now see the cipher shoots. These are the supported cipher shoot at my Dubai WAN as routers. So these are the supported cipher shoots. Same thing you will get here as well. And your client hello, you have a supported cipher shoot, but they are using here 21 cipher shoots. You will see here some ECDHA, RSA and all, but in this you will only see you will see only with AES-256 and SHA-364, SHA-384, and your these are the three ones it is supporting. So in backend, your WAN is routers, they are using SHA-384 as a hashing algorithm and AES-256 as an encryption algorithm. And after that, you will get the compression method, which is null right now, and you will get all these extension fields. You will get all these extension fields, guys. This is the DTLS first packet. You will see all the signature algorithm and everything here. They are using these heartbeat messages basically as well. This is the DTLS packet. See the things here. Compression, then you have a server name and other things here, right? You have some extension fields. Now look for the next message, which is server hello, server certificate, and server hello done. So here you will get three messages together, guys. And this is the little bit big message, guys. Okay, it's a little bit big message. But now if you will see your DTLS here, we have a server hello, but it's a fragmented message because fragmented is happening. It's a packet with higher size, and you will see this is the another packet. This is the reassembled packet. So these are the two packets which include your server hello, server certificate, and server key exchange, and all these details. If you will open these messages, you will get the details here. And they have agreed on this particular algorithm they will use for the encryption and hashing purpose, guys. And you will see all the details here. But in your record layer, if you will see, they have added the sequence number field. But if you will see the same value for your DTLS or for this packet, you will not see anything with regards to the in record layer. You don't have anything with regards to the sequence number here. So this is the new field which is introduced by the DTLS. So you have a sequence number and epoch values. For the fragmentation, they are using these values because all these things your DTLS needs to take care basically. So they say you in DTLS you have a client hello, you have server hello, server certificate, server key exchange. If you will open this message, you will get all the things with regards to. So here you will see around 4 messages: server certificate, server key exchange, certificate request, and server hello done. Because guys, why it is sending the certificate request? It is sending the certificate request to B bond. So your B bond will also authenticate. Don't worry, this part we will discuss guys in your tomorrow class on during the bring up process basically. So that time we will use these particular captures. I will write everything in detail, don't worry. Okay, so then we have a client key exchange, and after that you will see they have some application data. Now your data is encrypted, you will not able to see anything. But if you want to see something, go to into this certificate. In this certificate, just open this certificate and you will see your details, which is issuer. If you want to see the issuer detail, you will get the issuer detail, country, New Delhi, all these things basically you will get who is the issuer of this certificate. This is the fragmented message. Now this is the signature value and all. This is the subject detail. This is the subject. This certificate is for. So you will get the details here. Country US. This is the organization name. viptela LLC is the company name. Common name is for. This is for B bond basically. This is the B bond certificate because B bond is responding. This is the IP address of B bond. Don't worry, this process I will discuss tomorrow in detail, guys. Okay. So these are the things which I want to cover with regards to your today's session. Why basically we have discussed all of them, and just remember guys one thing. This WAN is basically all these WAN is routers. They will basically communicate with these controllers with by using the protocol which is DTLS. And your these vManager with vSmart, vManager with vSmart this, or with vWAN, all they will also communicate over DTLS. Each and every controller also make the connection with each other, and that part we will discuss in your next class. That's why the next class is also a very important class. If you will understand these things, you will get the whole idea of the everything. Because see, these are the main things which I'm going to discuss in your next class. These control connections, how the SD-WAN fab bring up happens, what are the events, what is the control connection to B bond, control connection to V manage, and control connection overview. So I have created everything here. If you will see, let me just give you some glimpse of it. So in your next class, we will discuss basically how your V bond and V manager or vSmart, they will communicate with each other. So these kind of connection they will maintain. If you will want to see these connection, I will tell you, if you will run this simple command, netstat -n grep, just put the IP address of your 10.1. Or let me just see what is the IP address of my controllers. It's 10.110. So if I'll search with that 10.110.1, hit enter, you will see all the connections. These are the UDP connection on port number 12346, 12346, right? What's that? How they will make all these things I'm gonna cover in detail, guys. Then how they will create the connection with the, how they will create connection with each other. What is the flow? Control connection to B bond, how they will make the connection with the B bond, then to your V manage, then to your controllers, basically, or V smart. This is the overview of it, right? Even though I will explain it with the help of Wireshark captures as well, because I generally used to use Wireshark a lot. So this is the plan from tomorrow session, guys, where you will get to see all these Wireshark captures and all. Okay. Everything I will explain in detail, so at least these things you will understood easily, guys. Okay, so because we have to go through with this bringing up process, I will share you this document as well, because here everything is written, but they have just written the things, and I will basically make sure you will understand everything, how they will communicate, how they will exchange these messages, and all. We will verify if it needed. I can also show you how we can decrypt these messages, because I know how we can decrypt these particular DTLS packets by taking the keys basically, because I have the certificate, I have the private key, right? And I can easily decrypt these messages. So we can able to also check these things, guys. Okay. Okay, so this is the whole idea of today's session, guys. Let me just stop the recording.